So what we're going to do now is we're going to give an introduction to Java. The first part of this discussion, which we'll partly do today, and then we'll cover the rest of it on Monday, is focus on the parts of Java that relate to abstraction and exception handling. And we'll probably get through a chunk of the abstraction part. I really want to get through the parts that relate to the programming assignment, and then the rest we'll leave for next time. There'll also be another set of slides, which we'll probably get to next Wednesday, which cover inheritance and dynamic binding as other important object-oriented programming features and language constructs that are part of Java. Hey, Will. And Will, this time I promise we'll actually talk about the assignment, which we got rushed last time. But I think he has to defrost first. There are lots and lots and lots of examples here, unlike the first discussion, which was mostly conceptual. These are actually real examples. So let's first start by talking about the simplest thing, the most fundamental thing. If you have an object-oriented programming language, then more likely than not, you're going to have some concept of a class. And the best way to think about a class is a cookie cutter that's used to create instances, which are the cookies, right? So the basic idea is a class is a way of grouping together methods and state called fields or data and so forth. So you can find out more about class here at this link. We'll use a running example through these slides. I try to pick examples that are real, not just fabricated. Every once in a while we have to fabricate one because the real ones are too complicated to get the point across. But the thing we're going to be using here is in the Java util package. We'll talk more about packages in a second. And it's the vector class. And vectors are pretty straightforward. In fact, you'll be implementing something along the lines of a vector for what we're doing for assignment number 1. So a vector basically implements a growable array of objects. We'll talk more about arrays later. Each element in the vector is of generic type E, which means that you can define something that will be the type of vector. And as long as it's a user-defined type and not a built-in type, then it should work fine as the parameter that you use to pass to the vector. So for example, we'll see here we could have different kinds of vectors. And if you recall, when we talked about generic programming, which is another paradigm, kind of a sibling paradigm to object-oriented programming, generic programming is all about being able to parameterize functions, parameterizing classes or data structures with types so you can reduce duplication of code, and you can also make the code more type safe. And we'll see what that means in a second. So it eliminates a lot of the drudgery of programming without these features. So here's a very simple example. We have a vector of int, of integer rather, and a vector of double. And as you can see here, if you say, vi set 0 to 10, then this goes ahead and works because this is a vector of integer. But if we try to do a vector of, if we try to put a double into the vector of integer, that will not work. That will not compile. And that's because 10.0 is a double value, and there's no automatic conversion in Java, the way that we're using it here, between double and int, or integer. Likewise, down here, we have a vector of doubles. And this time we can put 10.0, but we can't put a 10. So that's an example of type safety, a very simple example of type safety. So you can't mix apples and oranges. You have to have things that are consistent. Yeah?
How does dynamic binding relate to this parameterization?
So dynamic binding, the question is, how does dynamic binding relate to parameterization or genericity, as the term is often used? They're really independent topics. The main thing to remember at this point is that generic programming and parameterization is resolved at statically at compile/link time. So by the time your program goes to run, all these issues have been resolved about the types that are involved, and the selection of the appropriate method has been made at that point. Dynamic binding, in contrast, defers until runtime the choice of which implementation is actually selected. And the reason for that, when we get to that part of the class later, is that there's some special lookup mechanisms that are used called virtual tables and virtual functions and dynamic dispatching and all this good stuff. And it actually uses the type of the object to dispatch the method. Whereas with parameterization, that's done in a more statically bound way as opposed to waiting until runtime in order to do the binding. In a language like C++, these distinctions actually make a lot of difference because C++ does optimizations in all kinds of cool ways with earlier bound types. With Java, some of the generic mechanisms are more syntactic sugar in a large measure, and so the opportunities for optimization are not as great. But the opportunities for type safety and eliminating the drudgery of typecasting and so on are still there. Now, something else to notice here is that with Java 7 and beyond, you don't have to repeat the type of the vector when you say new vector. So in Java 6 and before, you'd have to say vector integer vi equals new vector integer. You'd have to actually put the word integer here inside these angle brackets. With later versions of Java, including Java 8, of course, you don't have to do that. So it's a little bit less verbose. It's another example of the don't repeat yourself principle that we talked about last class as a way to avoid unnecessary duplication of stuff. Each Java, yes, sir. Will these vectors be instances of the same class? No, they would not be instances of the same class. One would be a vector of double, the other would be a vector of integer. And so those types are different, and as you can see here, you can't mix them. You can't try to assign a double to a vector of integer. You can't try to set an integer to a vector of doubles, and so on and so forth. So they're actually typed. Yes?
Does Java allow implicit typecasting?
Java is much less implicit-oriented than C++. In terms of moving between different types, like moving between double to float and int and long and so on. It's much more explicit. There are some situations where the Java compiler can figure out how to do so-called type deduction, where you can eliminate having to put type information in if the compiler can unambiguously deduce it. But Java is much stricter than C++ and C as far as moving things between different representations, which is actually not a bad thing, honestly. Every Java class has to go into its own Java file. This is a little bit weird at first if you come from C++, but it also makes some sense because whenever you see a file, you can be sure that there's a class with the same name nestled in there somewhere. So vector class is in vector.java, which is in Java util. And if you follow the links I gave last class, you can actually find the source code and look at it. And there's lots of interesting things in vector. Probably won't help you much for your assignment, but it's interesting to look at. Unlike C and C++, and this is sort of a minor point, in C and C++, you have a choice. You can either put the definitions of the methods in the header file, or you can put the definitions of the methods in a separate .cpp file. And the same thing is sort of true with C as well. You have .h files and .c files and so on. In Java, everything goes in one place. It goes in the .java file. So they don't make a distinction in Java between headers and implementation files. And the way that that works in practice is you typically read the documentation through some web-based interface that's been spit out of a tool like JavaDoc or Doxygen and so on. And so the things that you actually look at are generated for you automatically, whereas sometimes in C and C++, you look at the header file to see what the signatures are of the objects or classes you're dealing with. Now, there's a bunch of funny things called modifiers. This is an example of making this class public. So anybody who uses this package can use this class publicly, so that's what that means. Every class resides in a package. And you can have the null package, but it's frowned upon. So in this case, it's in package Java util. And packages basically group together related classes. There's a whole pile of stuff that comes out of the box in Java. You can see Java, lang, string, thread, and so on. These are the sort of the core types. You don't even have to refer to them by their package. They just exist as part of using Java. Other things like JavaNet, Java Applet, Java util, Java I/O. Those things are in packages, and you typically have to do something special to get access to them. And we'll talk about what that special thing is shortly. If you're familiar with C++, and I don't expect you to be familiar with this feature, but if you are, packages in Java are not unlike namespaces in C++. They're a way of grouping things together. So here's an example where we have two functions in C++, both of which have the same name called value, but one of them is in namespace foo, and the other one is in namespace var. And so as a result, foo and bar are the namespaces, so we can unambiguously refer to both of them by prefixing the name with the name of the namespace. And a package works much the same way. You have a lot of control over how you organize packages. It's up to you to decide how you want to put them and how you want to arrange them. There's a particular way of naming stuff within packages. So with our case of Java util vector, if you want to refer to this thing, the package name is java.util, and then the dot is the way you get to the vector. This syntax is ever so slightly different from C++, where you typically refer to classes that are nested by : whereas in Java you refer to them by dot. Not a big deal, just a small minor inconsistency between the languages. The packages that you see logically in your design are also represented physically in the way that the files are laid out in the directory hierarchy that actually stores the source code. And so as a result, we would have Java util vector would be in the Java/lang. Actually, well, that should say Java util. Assume for sake of argument. So it's in fact correct that things that are in the java.lang folder are in the java.lang package, or in the java/lang folder in the file system. This should be updated to say java.lang instead of java util. All right, so that's a really quick overview of classes. Now there's a lot more we're going to say about classes, and we will say about the classes. We'll go through fields, we'll go through methods, we'll go through nested classes, we'll talk about constructors and all that kind of good stuff. We'll talk about something called abstract classes. But before we do that, I want to talk a little bit about interfaces. And the main reason I want to talk about interfaces next is you'll have to know something about interfaces in order to do the first programming assignment. So let's talk about them. So in some sense, as we'll see in a second, an interface is kind of a skinny class. It's kind of a little bit, it hasn't been working out quite as much. So an interface is basically a way of specifying a contract that defines a set of methods that have to be implemented by somebody in order to be able to fulfill that contract. So it's really defining an interface. It's defining an API. So here's a simple example. We'll see a lot of this later in the course. Interface runnable, very, very simple interface which defines one method called run. And you can find out more about interfaces here. So interfaces are intentionally less powerful than classes. They're meant to have a lot fewer capabilities, a lot fewer features, and we'll see why that is later. Although honestly, it's a little bit confusing at times why they did what they did, but there are good reasons for this. Interfaces can only contain certain things. They can contain constants, which in Java are basically finals, static finals, method signatures, which are things like public void run, default methods, which we'll look at later, static methods, and nested types. Those are the only things you can put into an interface. You cannot define fields, for example. You can't have private or protected methods. There's a bunch of things you can't have in an interface. You can only have in a class. They also reside in files, just like classes do. An interface is implemented by a class, and there's a whole bunch of different ways to do this. We're going to talk about two of the ways right now. I will mention the third way just briefly, and we'll come back and cover it a lot more in detail later. So here's a very simple example where we have named classes. So here we have public class runnable impl implements runnable. So that's a named class. Here's another runnable impl, which implements runnable. Those are both examples of named classes. And you can see what they do is they implement the run method to do stuff. We're not going to think too much about what they're doing. It's not really part of the discussion. Here's a case where we make an anonymous instance of a named class, and we call the method. So we say new runnable impl, so that makes an anonymous object. We didn't call it something. We didn't say runnable impl, my runnable impl equal new runnable impl. We just said new runnable impl. That's the anonymous part. And then we immediately call its run method. Now, if this was C++, this would be a memory leak. In Java, this is just something to be collected by the garbage collector at some point shortly thereafter. So we're running these things. And if you were to run this, if you compile and run it, it'll print out these messages. That's one way to do things. Runnables get used very widely throughout Java. The most common place that runnables are used is with threads. When you create a thread, you can give it a runnable, and that'll be what's used to actually do the business logic, the application code. But we use runnables for other things as well. They're basically commands. And we talk about the command pattern later in the course. You'll learn more about that. Here's another way of making these implementations. These are what are called anonymous classes. So in this particular case, we're saying new runnable, and then we're defining the run method sort of in line. There is no class. Over here, there was a class called runnable impl that implements runnable. Here, we're just saying new runnable, and we're defining a run method. And then we're calling run. Now, we don't have to do that. We could assign it to a variable and call it later. And we'll see an example of that in a second. But this is an anonymous version. And here's a case where we're making an anonymous instance of an anonymous inner class. And it's inner class because, of course, this would have to be nested inside something else. Yes, sir? Right. So the question is, what's actually going on here? So we're making ourselves a new object, which is of type runnable, and it defines a run method, and then we're calling run. Now, this idiom is used all over the place. Probably wouldn't be used quite like this for this particular example, but it illustrates in Java you can make anonymous instances of something and use them immediately. So that's very common. You will see stuff like this used all over the place, especially in Android, where you need to have callback buttons handlers that are dispatched for click listening and click handling. Yes? What's that? So we're actually implementing an implementation of an interface using an anonymous class. So here we had a named class runnable, right? We gave it a name. Here we're just defining ourselves an implementation of the runnable interface, but it's anonymous. So there's no name other than the fact it can be called and have things done to it.
So can you have an anonymous subclass like this, and also what if you don't want to implement what if you want to have the anonymous?
So yes, you can definitely have anonymous. Well, anonymous subclasses are kind of a funny thing, but yes, you can have anonymous subclasses, although this is not an anonymous subclass. This is anonymous implementation of an interface. It's an anonymous class. It's implementing an interface. But you can also have anonymous subclasses as well, as we'll see when we get a little further along. What was the second part of your question?
What if we just wanted an anonymous class that wasn't implementing an interface?
You would have to have it implementing some interface, right? It would have to be an interface or an abstract class. It has to have something. But we'll see some interesting examples on the next slide that might be closer to what you're asking. All right. So here is the coolest thing. This is called lambda expressions. And here's a case where we're making ourselves a runnable, which is simply going to be a function with no parameters, like run, which is what it has, and we're just giving it an implementation. So we're making ourselves a runnable, which is just going to be given an implementation that prints something out, and then we're saying r1.run or r2.run. So this is a brand new Java 8 thing. We'll talk a lot more about it in class. It's the utmost in syntactic parsimony you will find in Java. And it's getting much closer to functional programming language features. Lambda expressions are a functional programming language feature. When you take 270, you'll learn more about that. I'm not going to talk a lot more about this right now, but this is something that's pretty cool, and it's very popular, and you'll see how it gets used in all kinds of cool ways later. All right. Now we're starting to talk a little bit more about what distinguishes a class and an interface. So one thing we'll learn shortly is that classes can only extend one other class. So you have single inheritance of classes in Java. However, you can have multiple inheritance of interfaces. So here's an example from the Java util concurrent package called runnable future. And runnable future extends the runnable interface, which we've already seen, and it also extends another interface, which we'll talk about later, called a future. And so it combines the interfaces of both future and runnable. So something that implements runnable future needs to provide not only the run method from runnable, but also the appropriate methods from future, unless they're default methods, which we're not going to talk about right now. And so the key method here is run, which is going to do all kinds of cool things. Conversely, a Java class can only extend one other class. Now, this is just a fun question. I don't expect people to know the answer. Does anybody know why Java has multiple inheritance of interfaces, but not multiple inheritance of classes? Yes, it's the dreaded diamond of death. And so we'll talk about this a little bit later. Actually, the great thing about it is in Java, you don't have to know or care about the dreaded diamond of death with respect to inheritance and multiple inheritance. In a language like C++, you do have to be concerned with that because they allow multiple inheritance. And so there's all kinds of weird ambiguities and issues of performance and space utilization that come up. The great part about Java is we can just ignore it altogether. Java provides a lot of interfaces in its class library. I'm going to talk about a couple here, one of which is important for the assignment, as we'll talk about in a second. So, and one interface is called comparable. And you can see comparable is an interface parameterized by type T. And you can use it if you implement the comparable interface. You can implement what it means to compare two instances of type T. Of course, your data structure would expect to be parameterized by type T. So, for example, in our case, we have a character array. So we're going to be, the T will be bound to character. If you made it a generic array, which we'll do for the next assignment, then it would just be whatever type T was passed there. Comparable is used when you are actually implementing a class yourself and you have control over what it means to do comparisons. So when we talk about the array assignment in a minute, you'll see how comparable works and how you'll have to fill in what it means to compare two things. So that's one type of interface. There's also something called comparator, which unfortunately has much the same name and similar concept. This is used in situations where you don't have control over the implementation, but instead you're going to be defining a comparison operation external to whatever data structure you're dealing with. So for example, if you were defining something to be sorting two strings, then you would have to define what it meant to compare them. And so you would use the comparator interface because you didn't write the string class. You're simply saying what it means to be equal in that context. So for your assignment, you'll have to do comparable, and we'll talk about that more in a second. Now, an interesting thing that is true with Java 8 and beyond is they have this concept of default implementations. So here's a simple example where comparator, in addition to forcing you to define a compare method, also gives you some default implementations. For example, reversed is a method that's a default, and it simply goes ahead and reverses the order in which the comparisons are taking place, and so on. And so default methods were added to Java 8 in order to be able to preserve backward compatibility when adding new enhancements to existing interfaces. And I won't go into the details right now, but it was a very useful addition and cleans up a bunch of awkward and verbose things you had to do with earlier versions of Java. OK, so you'll have to figure out how to do comparable for the assignment. You'll have to implement that. Some more things you'll have to know for doing the assignment is dealing with so-called primitive types. Java is a little different from C++ in this respect. C++ works harder at trying to make built-in types and user-defined or library-defined types interchangeable. Java sort of says they're different, and they provide you some support to make them coexist, but it's definitely a second-class. Built-in types are definitely a second-class citizen in Java. So these are the classic built-in types: integer or int, double, boolean, byte. Everything's lowercased here. I expect you to know what these things do. If you do not know what a boolean is, or an int, or a double, you're probably in the wrong class. You're probably in the wrong major. Okay, so I expect you to know what those things are. You might or might not know this. You can have things called boxed types, which are basically ways of being able to take built-in types like 1 and 1.0, which are built-in literals for integer and double, and convert them into the class equivalents of the built-in types. And in fact, this is such a common thing to do, they actually do these conversions. This is one case where conversions are done for you automatically. Notice how you create new instances of things by saying new. I expect you also knew that too. Here's a case where you can assign the built-in types, and there's automatic conversions that take place to convert these things into the integers or doubles. And then you can also go from these built-in, these user-defined types back into the built-in types. So that boxing, it's called boxing and unboxing. That's done for you automatically. You can also take strings and convert them in various ways. So here's an example where you can say integer.parseInt, and you can give it a string, and it'll turn it into an int or an integer. You can also say parse double, and it'll turn it into an int or an integer, and so on. You can see that parseInt is something that's called a static method. You don't need to have an object in order for it to work. We'll talk more about that later. And of course, you can also see that there are different ways to do comments in Java as well. All right, so those are built-in types. I'm expecting that stuff isn't very surprising. Arrays, a little bit more interesting, and you definitely need to know how they work for the assignment, so let's talk a bit about those. So arrays in Java are a little bit different from arrays in C and C++, but they're basically the same syntax in many ways. Here's an example where we have an array of foo, And we're going to make a new array of 10 foo. So there's 10 foos now. And the thing to remember is when you create one of these things, by default, each element is null. And so if you want the array to have something useful in it, you have to come along and make a new one. So here's we're going to say my foos sub 0. Remember, all arrays in Java, like C++ and C, start at 0. That's going to be given a new foo. And then once we've done that, we can go ahead and we can read the value here. So we can go ahead and get back a foo from my foos sub 0, because we've already assigned it there. And then if you check for a foo that we have not yet initialized, it will start out with null. So it doesn't have uninitialized values, but they're not initialized to anything other than null. And you can also, of course, create arrays of primitive types, as well as user-defined or library-defined types. So here's an array of 5 ints. And notice that every array keeps track of how long it is. So you can say the name dot length, and that gets you the field that keeps track of how big the array is. Now, one of the things, of course, that you don't get with these arrays is they don't automatically grow and shrink. So that's what your array class is going to do. It's going to add the ability to be resized. And we'll talk about that in a second. Here are some helper methods that you need to understand in order to be able to use this stuff effectively. So for example, there are predefined methods and classes that can be used to build and use built-in arrays. Here's a simple example. We have something called array copy demo, which you can read about here. And it's got a real simple behavior. What it's going to do is it's going to create an array of characters which says decaffeinated. And then we're going to create a copy of this thing. And then we're going to use the system.arrayCopy method to copy from this array and stick it into this array. So we're going to start at location 2, which is right here. And we're going to copy to location 0 here. And we're going to copy 10 characters, which will change decaffeinated to caffeinate, just for fun. So that would be one way to do things. Notice in Java, like C and C++, you need to have a main function for any program. So somewhere there needs to be a function called main that's a static function. And that serves as the entry point into your program. Here's another way to do this. This is just a different way. This is using the array copy method that's defined in the system class. There's also an arrays class, which you can read about here. And there's a bunch of useful methods like copy of range, which is just a more succinct way of being able to copy from this array starting at location 2 and copying the appropriate number of characters or up to this location at the end. And so that's one thing. And then this is another very useful method called fill. STL, C++ STL also has a fill. It's not quite as cool, or it's more cool than the Java fill. But basically, in this case, we're going to go ahead and fill the copy to array with the character literal B. And there's a whole bunch of different ways of doing filling. So if you take a look at this documentation, you'll find out lots of different ways. So I think you probably now are armed with what you need to do most of assignment 1. Yeah? Yes, because it knows length, right? So array, unlike C and C++ built-in arrays, which don't keep track of their length, typically, with some caveats, in Java, they know how big they are. And the .length field is what is used to get it. Yes, sir?
Sorry, what is filled in? Does it replace every letter B?
It'll replace everything in here with the letter B, exactly, yes. Any other questions?